Geology students, this is the last video you're going to get before the third test coming up. And please don't forget that the third test is on April the 5th at 7 p.m. Chapter 11 is what we're going to finish today. And Chapter 11 is about late Paleozoic Earth history. And what it specifically refers to is the Devonian, Mississippian, Pennsylvanian, and the last period of the Paleozoic, the Permian. It's important to note that one of your authors was trained in Great Britain, and he uses the terms Carboniferous. Carboniferous refers to the Pennsylvanian and the Mississippian combined, and in Britain they call the Pennsylvanian the Upper Carboniferous and the Mississippian the Lower Carboniferous, but we're going to use the American terms Mississippian and Pennsylvanian. Okay, so let's cover that period, the late Paleozoic history of the planet Earth. Really an interesting topic. First thing you want to remember is that most of the Earth's coal formed during the late Carboniferous, otherwise known as the Pennsylvanian Period. So most of the Earth's coal formed when? During the Pennsylvanian Period. Think of the Keystone State. Think of the nation's first capital, Philadelphia. Think of Joe Pa, Penn State football. Think of the Pennsylvanian Period, when most of the Earth's coal formed, including Tennessee coal. Coal is still important to our economy. It provides most of our electricity. It's important in the manufacture of steel. And also, it doesn't say so here, but we get rare earth elements out of coal. Rare earth elements. I recently gave a talk to various government officials in Washington, D.C., about rare earth elements. The president of the college wanted me to give a talk about it. Rare earth elements are used in the manufacture of cell phones, computers, electronics, for the civilian sector, and for the military sector for missile guidance systems, radar, and sonar. And so they are strategic importance, and the government and it's a rare sign of bipartisanship where the Republicans and Democrats are working together so that we can get rare earth elements out of coal. We can get it out of coal. We can get it out of coal ash. That's the ash that's produced after you burn the coal. And we can also get it out of the wastewater that comes out of coal mines. So coal is used for electricity, steel, and rare earth elements. Obviously, with the climate change problem, the government is trying to move away from coal into green energy. But, in my personal opinion, we're going too fast. All those people who had $5,000 electricity bills and $10,000 electricity bills down in Texas, in oil and gas country, they shouldn't have those power shortages. And that shows the problem of just completely relying on wind and solar. When you have bad weather conditions come up, then people don't have any electricity. Yes, we have a climate change problem, and we do need to stop burning fossil fuels and plant more trees. But we can't move to green energy too fast, or our economy is going to collapse, in my personal opinion. So, the first period that we're going to talk about is the Devonian Period. Remember, in the previous chapter, we talked about the Cambrian, the Ordovician, and the Silurian. Now we're talking about the Devonian. The important thing you want to remember about the Devonian is that's when Laurasia formed. Remember, there used to be two separate continents, Laurentia and Baltica, well, they came together at a continental convergent plate boundary. They were sutured together to make a new continent called Laurasia. And when did that occur? It occurred during the Devonian. Each of those periods, you want to remember what happened. The Devonian is when Laurasia formed. Now we're going to talk about the Mississippian Period, otherwise known as the Early Carboniferous. Unfortunately, he uses British terms. But this Early Carboniferous, just translate that into Mississippian. What happens next is the continents start to move closer together during the Mississippian. That's what you want to remember. All the continents start to get closer together during the Mississippian Period. By the Pennsylvanian Period, otherwise known as the Late Carboniferous, you can see the continents have almost collided together. They're getting real close to coming together. Everything comes to a crescendo during the last period of the Paleozoic, called the Permian. That's when all the continents join together to make Pangaea. That Pangaea came together how many million years ago? At the very end of the Paleozoic, 245 million years ago, Pangaea came together. Imagine that world 245 million years ago. We had one continent and one ocean, and the ocean was called the Panthalassa Ocean. When Pangaea came together, the Paleozoic era ended, and that would set the stage for the dawn of a new era, which we'll talk about after the next test, called the Mesozoic era. The Mesozoic era going from 245 million years ago to 65 million years ago. But right now we're still talking about the Paleozoic era. Remember, we formed large coal swamps. Coal forms in swamps and bogs. And those primarily occurred during the Pennsylvanian Period, and to a smaller extent in the Mississippian Period. But most of the world's coal formed during the Pennsylvanian Period, including Tennessee and Kentucky coal, and West Virginia and Pennsylvania itself. Notice I'm not covering every single thing. Reason being is we don't have enough time, and I want to get to the later chapters, the chapters that interest people the most, the parts about dinosaurs and humans. So I'm going to just cover the main points. Let's focus a little bit on our continent of North America, which during the later part of the Paleozoic we called it Laurasia. Take a look at this picture here. This is what North America looked like during the Devonian. And during the Mississippian. So during Devonian and Mississippian time, we had one long mountainous island. And what happened is this. Laurentia and Baltica collided together to make Laurasia, forming this huge mountain range that sutured those two formerly separate continents together. This is the beginnings of the Appalachian Mountains right here. The Appalachian Mountains finally came together 290 million years ago. As rivers flowed down these mountains, they deposited sand along the coastline, and so you had beaches all along the western margin of this rocky island. You had a tiny little bit of mountain building occur here on the west coast, and they formed these antler mountains that no longer exist, that were eroded away. But for the Paleozoic era, please don't forget, the mountain building almost entirely occurred on our east coast, not on our west coast. West Coast mountain building would not really begin in earnest until the Mesozoic and Cenozoic era. Another way of saying it is, the Rocky Mountains did not exist during the Paleozoic era. And another thing to remember is the Appalachian Mountains are a lot older than the Rocky Mountains. Also, during the Devonian and Mississippian, we formed a basin. Again, you can see these reef deposits, and then here in British Columbia, which is a province of Canada, you had evaporites forming all of those valuable evaporite mineral deposits that we talked about in the previous chapter. Gypsum for wallboard, halite, which is salt used to melt snow and also as seasoning on foods, and barite for engine cleaners, fuel injector or carburetor cleaners. And then we also have these important coral deposits around the Williston Basin that are filled with oil and natural gas. This Williston Basin is very important to the Canadian economy. You know, I was watching this video and I was amazed when they were talking about the economy of British Columbia. They actually have a budget surplus. Think about our situation. Our government is $15 to $20 trillion in debt, and we're spending money like there's no tomorrow. And all the states are having budget problems. The Canadians actually have a budget surplus for British Columbia. They have more money than they can spend. Why? Because of all the oil and natural gas in these reef deposits formed during the Silurian and Mississippian. And these evaporites are also extensively mined. And a lot of the drywall we have, some of it comes from the Michigan Basin, formed during the Silurian, but a lot of it comes from Canada. We import it from Canada, from these Devonian Mississippian deposits from the Williston Basin. Another important economic potential deposit is black shale. Remember shale? It's a sedimentary rock made of clay. This is what shale looks like from Kentucky. Notice it has this blackish look to it. We find it in Tennessee as well. Look at all the black shale we have in Tennessee, especially around going up from Chattanooga all the way up to Johnson City and central Tennessee. These black shales are black in color because they're filled with oil. I think you've noticed that over the last year, oil prices have been going higher and higher and higher. How much is it at the gas tank right now? It's getting to be $2.60 a gallon, and it's going to keep going higher. Well, when oil prices get high enough, we could start to get the oil out of these black shales that were formed during the Devonian and Mississippian period. These can, if we start to frack these shales, and what is fracking, by the way? I hear all these people talk about how horrible fracking is, and you see all these movies about the environmental consequences of fracking. But fracking provides hundreds of thousands of high-paying jobs. It adds hundreds of billions of dollars to our economy. We now can take natural gas and liquefy it and ship it overseas, reducing our national deficit. So it's not so simple. I think that fracking is a big boon to the U.S. economy and can produce lots of jobs, keep our energy bills low, and keep the money in the United States. Yes, we need to protect the environment, but by sending these pressurized fluids into the water, it fractures this black shale, and we could get the oil out of it. Also, think about it from a national security perspective. We're sending hundreds of billions of dollars to the Middle East, to many countries which are sponsoring terrorism. Shouldn't we keep the jobs in this country? I'll get off the political soapbox, but I don't think it's good for the country to just move off of oil and natural gas too quickly. Here you can see that we got natural gas in all these black shales all around the country. Parts of Tennessee, the unemployment rate is 15 to 20%, and young people don't have a future. They're forced into minimum wage jobs and poverty. You go to North Dakota, the unemployment rate is extremely low because of fracking of these natural gas to get natural gas out of the ground. And that benefits the entire the entire state of North Dakota, because with all these high-paying jobs, people go to restaurants, they buy things, and the economy is booming in North Dakota. So once again, so in the previous slide we saw the Devonian and the early Mississippian, but now by the middle and the later parts of the Mississippian, you can see that the mountain range here starts to erode away a bit. We still got the Williston Basin, and we have this small rocky island called the Antler Highlands. By Pennsylvanian time, notice that these mountains back east have started to erode away. And now, during the Pennsylvanian time, we finally form what we call the Appalachian Mountains, 290 million years ago. And this small mountain range over here, going through Arkansas and East Texas, called the Ouachitas. We do have a little bit of volcanic activity in the Pacific Northwest, but most of our mountain building is going to occur during the Mesozoic and the Cenozoic on the west coast. Notice all of this green area. That's the important parts right here to our economy, especially in Appalachia. Coal formed during the Pennsylvanian Period. Most of the world's coal formed during the Pennsylvanian Period in these swamps like we have in Tennessee. Coal can be burned to make electricity. We can get rare earth elements out of coal. Coal is important in the manufacture of steel. I don't know if you know a lot about the coal we have here in Tennessee, but the coal can be easily found if you understand the concept of cyclothems. Here you can see a typical sequence of sedimentary rocks, and here's the coal right here in black. And there it is in photograph. I'm sure if you grew up in Tennessee or Kentucky, you've seen this black coal. I made friends with some people who live in Scott County. James West and his family have been mining coal for a long time, and they know how to find out where the coal is because they understand the concept of a cyclothem. This sequence of sedimentary rocks appears again and again, so there'll be another one of these above, another one of these above, another one of these above that, so that therefore if you know the thickness of these cyclothems, you know exactly how deep you have to go in order to find the next layer of coal. As I mentioned before, coal forms in swamps. And what happens is that here you can see you got non-marine sandstones and then you've got your coal, and all of these were formed on the land. And above that, you got all of these marine rocks, mostly limestones. So what this is showing you is that you have a land environment, then you have coal swamps, then sea level rises and covers up those old swamps, killing the swamps. So coals are no longer formed, and then you form a huge thickness of marine rocks, including marine shales and marine limestones. And then you have then sea level will fall again, and you'll form more non-marine rocks, and then your coal, then sea level will rise and cover up those coal swamps and kill them. So you have cyclothem after cyclothem after cyclothem, and if you can recognize these sequences of rocks, you'll know how deep to dig to get to the next layer of coal. This is what a coal swamp looks like the ones we had here in the great state of Tennessee. Notice how everything is covered by a foot or two of water, and it's filled with vegetation. Swamps are filled with vegetation. When these plants die, it covers the bottom of these wetlands, they're considered wetlands, with thick accumulations of vegetation. This vegetation eventually is going to be compressed over time to make peat, P-E-A-T. Let's take a look at what peat looks like. Peat. Have you ever been to England or Ireland? If you have, you've seen these peat bogs. This is what peat looks like. And it's just compressed vegetation from ancient swamps or bogs, like the bogs of Ireland or England. This is the first step in making coal. Then the peat is going to compress, and over millions of years or tens of millions of years, it's going to become more pure as the impurities leave it, and it's going to make lignite, L-I-G-N-I-T-E, which the coal miners call brown coal. This is a lot cleaner burning than peat. It has more of the contaminants removed. But we're no longer allowed to burn this stuff, and rightly so, because this is a highly polluting source of energy, lignite. Over hundreds of millions of years, that lignite is going to become the coal we see here in Tennessee and in West Virginia and in Kentucky, bituminous coal, which is a sedimentary rock that you have seen before. You've seen this coal before. Small amount of coal will get metamorphosed if it gets buried deeper in the earth, and that makes the best coal, which is a metamorphic rock called anthracite coal. This is the cleanest burning coal there is, anthracite coal. It produces the least air pollution, it releases the least amount of carbon, and this is what coal miners call black gold. Fortunately, only 2% of the coal in the United States is anthracite. So, by Permian time, this is what Laurasia looked like. Because the Appalachian Mountains have started to rebuild, there's more subduction occurring along the East Coast. You get some coal swamps here, going up into Canada. Most of the coal, though, was formed during the Pennsylvanian, don't forget. And then we formed the famous Permian Basin, formed during the Permian Period. Again, you have your reef deposits here. And this is where Texas oil comes from. These old reefs associated with the Permian Basin. Permian Basin's famous for oil. Texas is famous for oil. Texas oil was formed during the Permian, the last period of the Paleozoic. Here you can see some of the reef deposits that are associated with the Permian Basin. And you can see sponges. Here's some sponge phylum Porifera, but most reefs are primarily consist of corals. And we find brachiopods in there and crinoids and phylum Mollusca as well. Don't forget, please, during the Devonian, Laurentia and Baltica collide together to form Laurasia. Here you can see some of the coal resources we have in the United States. Anthracites in dark brown, obviously that's the best coal. Then we got the purple areas, the kind of coal we have in Tennessee, bituminous coal. Lignite, which is not clean burning, and subbituminous coal, which is not as good as bituminous coal. The future of coal is dependent on politics. Bottom line is Democrats want to stop all coal mining, and Republicans want to stop coal mining but do it in a slower way. And I guess that's enough to cover before the final exam. Make sure you watch all the videos. Don't think you know everything, especially if you're not doing good in the class. If you watch the videos carefully, and I hope you're going to do well on this next test.